Hello and welcome to Chapter 12, Experiments with More Than One Independent Variable. Such designs are often called factorial designs to indicate that there is more than one factor, more than one independent variable of interest in the study. It also has multiple groups in the same sense that we've been talking about earlier for between subjects designs and so forth, or within subject design where there's more than just two conditions. You can have 3, 4, and 5 conditions. But arranging the data when the opportunity presents itself as a factorial design has some advantages. If you can imagine your distinguishing features between the various conditions of your studies as having more than one variable upon which they differ from each other. Usually that's an explicit goal, but sometimes it's something you kind of on evaluation notice and recognize. Then you want to be able to take that into account. And by doing so, you have tremendous gains and value for your research study. You can look at the effects of the individual independent variables contributions. You can look at how they affect the dependent variable, but you can also look at something called the interaction effect. And the interaction effect is where the real power is. How does one variable's effect on the dependent variable change depending upon what's going on with the other independent variable? We'll make that all more clear in just a little bit. So we have a basic study here of 4 groups. We're imagining a study. We're going to imagine that we're examining the effects of a sleeping pill and alcohol on drowsiness in people. And what we've got is 4 conditions, one of which would be considered probably a control condition, no pill and no alcohol given to the person, and we measure drowsiness across a large number of people, how much it increases from in the person. And then we have a condition where there's no pill given, and yes, they took some alcohol that's of a measured quantity, or yes, they took a pill that is believed to a sleeping pill, and no alcohol was given, and then both, yes, the pill and alcohol is given to them. Now, the numbers you see up there, those are representing an average across several people that were in each of these conditions. For instance, we might have 5 or 6 people in each of the conditions. 5 or 6 people were not given a pill nor alcohol, and therefore they come in at an average of 0 drowsiness change. Those persons in the no pill, yes alcohol, no pill given, they were given some alcohol. Those 5 or 6 people, however many it is in this imagined study, average to a 3, and so forth. Now we can rearrange this data. And once we do that, once we recognize that this pill and alcohol characteristic is really 2 variables, and we can rearrange the data and take advantage of it in our analysis. As you can see, these things neatly fit into the locations, still making sense. The no pill, no alcohol average of 0 goes into the cells that are connecting no pill and no alcohol. They have the combined condition of being no pill and no alcohol given, and so forth for no pill and yes alcohol, and yes pill and no alcohol, and yes pill and yes alcohol. We can then graph this. We can show the outcome of the study in a graphical form, and once we do that, things start to become kind of interesting to talk about in a couple of 2 or 3 ways. The first thing you'll notice in this, where I've got, is how you graph something like this. You've got an x-axis that is for one of the independent variables. Your y-axis is used for your dependent variable, which is usually the case in most all studies. The 2 lines, each of them is representing a different alcohol condition. The lower line, the brownish line, is representing no alcohol, and the more green colored line is representing yes, the person's had alcohol. And so the left hand green dot is representing no pill and no alcohol, or representing no pill but yes alcohol given to the person. So what we want to do is talk about what the value is we're gaining from this. We get a tremendous amount of value in our factorial designs because we're able to efficiently examine 3 simultaneous research hypotheses: the effect of one independent variable on the dependent variable, the effect of the second independent variable on the dependent variable, and the combined effect of the 2 independent variables on the dependent variable. Do they influence each other's effects? We're going to examine that a little bit. To look at it specifically for this particular imagined study, is there an effect of pill on drowsiness? Is there an effect of alcohol on drowsiness? And is there an interaction between the pill's effect and the alcohol's effect on drowsiness? That is to say, does the effect of alcohol differ depending on if the pill has been taken or not? So we go back and look at the graph, and we see that there is what we refer to as a main effect for pill. That's just testing whether or not the pill had an effect. You'll notice that we're kind of ignoring the fact that there is a no alcohol and yes alcohol condition. We're averaging between the two to get a 1.5 for the no pill condition and a 6.5, the average between 4 and 9, for the yes pill condition. We've done what's called collapsing across alcohol, collapsing across that variable. We're not paying attention to that fact. We're just looking at, on average, for all of our participants that did not have a pill, and for all of our participants that did have a pill, what is their the difference between those two groups? And that would be represented graphically simply by a line that's between the two lines that we started with. And we see that it slopes upward, that persons who had the pill have a larger increase in drowsiness than those that did not have the pill. We would declare that to be a significant main effect of taking the pill. Similarly, we can examine whether or not there's a significant main effect for taking alcohol. What we see is, averaging across the pill conditions, that is, ignoring the fact that some persons had taken a pill and some had not taken a pill, collapsing across pills, so to speak, we would see that the average of all the participants who did not have any alcohol is 2.0, and the average of all the persons who did have alcohol is 6.0. And we can look at that, and we see that it's really just the difference at the midpoint of the two lines that represent the two groups of alcohol consuming persons. And that represents the main effect of alcohol. And then we've got the interaction of pill by alcohol. This is where it gets a little bit interesting, and we want to be very careful how we talk about it. We notice first that in the no alcohol condition, the increase in drowsiness from no pill to yes pill is plus 4 points. And that in the yes alcohol condition, the increase in from no pill to yes pill for drowsiness is 6 points. Now this is evidence of an interaction effect. The effect of alcohol is 4 points if you did not have a sleeping pill, but is 6 points if you did have a sleeping pill. That is, how much effect there is due to alcohol depends upon whether or not you had a sleeping pill too. And so we're able to say that the alcohol and the pill interact. And that becomes very important for our understanding of the study. For the data given, we can then therefore say that there is an effect of pill on drowsiness, there's an effect of alcohol on drowsiness, and there's an interaction between the pill's effect and the alcohol's effect on drowsiness. That is, the effect of alcohol differs depending on if the pill had been taken or not. Now that's just one outcome that can occur with a 2 by 2 factorial design, as we refer to it. There are actually 8 patterns. They don't have to be all 3 hypotheses confirmed, as we just saw. And these 8 patterns are taking into account all the various ways that the 3 hypotheses may or may not be confirmed. And a key point here is that the statistical and logical analysis of these 3 hypotheses that we've been talking about, the main effect for one variable, the main effect for the other variable, and the interaction of the 2 variables, are statistically and logically independent of each other. That having a statistical confirmation for one of them in no way gives us any clue as to whether or not we would have a statistical confirmation of the other one. They do not imply anything about them. Now, for interpretation purposes, there's a whole different ballgame going on, and we'll talk about that in a few moments. So there's 8 possible patterns or outcome for any two-way ANOVA study. And here's what they look like. Now, your book has very, very similar graph to this on page 3. Let me get to that page in the book because I forgot to remember it. This is kind of silly for a recording to have a long pause like this. Page 360 and 361. Now, the book does a real good job with these. It has a great example that it's using for cell phone, people being on a cell phone, younger and older drivers, etc. I'm modeling my examples on the alcohol and pill interaction situation. What I want to point out to you is that in the book, there's an error. It's not a huge error, but it's important to talk about. That if you look in my graph here, you'll see that the left-hand middle row one, where I indicate not in the book, where there's a significant main effect for one variable and a significant main effect for the other variable, but not a significant interaction. That kind of situation is not represented in any of the 8 graphs in your book. Your book has 2 versions of a main effect for one variable, main effect for the other variable, and an interaction effect. That is to say that it is 2 versions of the graph. And if you're looking at page 360, it's the last graph on page 360 and the top graph on page 361. While they're visually different from each other, from a statistical and logical analysis perspective, they're actually equivalent, and therefore they are not distinctive from each other for the purposes of these kinds of discussions. And there's no example that models what I have graphed for the middle left-hand one that's a significant main effect for pill and significant main effect for alcohol, but no significant interaction. So you want to be aware of that. And if you look at the upper left one, it says no significant main effects or interactions. Just 2 flat lines that are right next to each other. And what that's showing is that it doesn't matter if on drowsiness whether you have alcohol or not. It doesn't matter if you took a pill whether you're drowsy or not. Of course, this is a very improbable result, but it's theoretically possible. It could happen if you in the gathering of data. From a falsifiability perspective, we can imagine this outcome coming, and that our theory that suggests that pills and alcohol should have an effect on drowsiness, well, we can imagine how we could falsify the data if we got a graph that looked like this, falsify our hypothesis, that is, if we got an outcome like this. That data could happen. Significant main effect for alcohol is the next one over, and no significant effect for pill, nor is there an interaction. And I'm not going to go through all of these, but I want to give you a sense for these graphs all match onto, except for the one I've commented on, page 360 and 361. Indeed, I think it would be a useful exercise for you to try to match up the ones that I have on my version of this in my presentation slide and the ones in the book, and try to discover how they're similar and how they're different, and are they really telling the same story in just slightly different ways in terms of a graphical depiction, so you can get a better understanding of these concepts. Now, how do we go about describing a factorial design? I've actually used some of these terms as I've been working along, because I like to do that, and then I'll come back and define them. I think actually it cements the ideas a little bit better in many cases, and I think this is one of them. We do have a shorthand that we use for describing factorial studies. And the basic shorthand is this: the number of levels of one of the independent variables with an x, and then the number of levels of the other dependent variable, that is 2x2. But that's not actually how we say it. It can look like 2 times 2, and that's okay, but that's not actually what we say. We actually say 2 by 2, as in kind of a Noah's Ark concept, if you're someone who's familiar with the Judeo-Christian story. 2 by 2 indicating that there's 2 levels of one variable and 2 levels of the other variable, and the x is being read as the word 2. The x, though, is really intended as a bit of a multiplication sign. The reasons for that are rather technical, and we're not going to get into here, but that is kind of what's going on. And mentally, when we see this, if someone says to you, well, I got a 2 by 2 study, in my mind I can immediately see, well, I've got one variable, another variable, one variable has 2 levels, the other variable has 2 levels. I can see that picture right there in my mind as soon as I hear 2 by 2. It's not hard. If I were to happen to hear 2 by 3, I would know that I've got 2 levels of one variable and 3 levels of the other variable. Not that hard to figure out. That's why it's a great shorthand. It's one of the few cases where there's really a good shorthand going on in how we describe things in this area of work. We're not limited to only 2 levels of each independent variable. As I was just saying, it could be 2 by 3. And in fact, the order is arbitrary. It could be described as 3 by 2. And we're not limited to only 2 independent variables. We could have 3 or more independent variables, such as mood, happy and sad, volume, low, moderate, and high, and gender, female and male. What's the shorthand for that? Using numbers. I'll let you think for a moment. I'm hoping you said 2 by 3 by 2. Though technically you could say 2 by 3 or 2 by 2 by 3 or 3 by 2 by 2. They would all be equivalent, but 2 by 3 by 2 tends to work a little better, I think. It doesn't really matter. Now, factorial designs do not need to be only between groups independent variables type designs. You can have a completely within groups factorial. An example of that might be all participants are experiencing all combinations of the independent variable. And imagine that we have video, a situation where we have people watching happy videos and sad videos, and they're watching them, and that's a video emotion variable, and they watch it in a warm space or a cool space. That would be a temperature variable. And I don't know what really you have as a dependent variable. Maybe it's how much they enjoy the video. I don't know. And we would still read it as a 2 by 2, but each individual in the study is experiencing all these things. So we're going to have a person come into the study. They're going to first watch a happy video in a warm room, and then they're going to watch a happy video in a cool room. Then they're going to watch a sad video in a warm room. Then they're going to watch a sad video in a cool room. Of course, you have obvious order effect issues, as we've talked about previously, and you would want to do a lot of counterbalancing. And it would be a pain to run this study, but it's, it could be created. You could do this study. You also have what we refer to as mixed factorial studies, in which the independent variable is a within groups variable and the other is a between groups variable. The Strayer and Drews study of the cell phones and distracted driving that's described in your text is of that type, where you've got persons on a cell phone or not on a cell phone, and they're either younger or older. Now, I should say to you, I have a lot of positive regard for the Strayer and Drews study. I have a lot of regard for both of these men because I knew both of them. Drews never taught me any classes, but David Strayer actually taught me cognitive psychology in graduate school. And so I know what kind of thinker he is. And they take their work very seriously, and they've done excellent work on this using driving simulators and such to collect excellent data. I know you don't like the data because it tells you should not be on your cell phone in the car. Well, tough. That's the data. I indicated earlier, and I want to reiterate, we can have the number of levels be increased, and we can have the number of independent variables increase. And what this does is it adds to complexity in the study. We can have I indicated you could have 2 or 3 or 4. You could have several levels of one independent variable. You could have several levels of both independent variables. And you can have several independent variables. But once you get past about 5 levels of one variable, regardless of what you're doing with the other one, but especially if you're increasing the number of levels of that other variable, and if you're getting up to 3 independent variables, more than 3, if you're getting to 4 independent variables, you're starting to get into some serious complexity issues and some serious problems with interpretation. With that said, I have a colleague that routinely does studies with 6 independent variables in them, a six-way design, 2 by 2 by 2 by 2 by 2 by 2. It's kind of crazy. I don't understand how he interprets it, and in fact I've told him I will not be a statistical consultant on those projects because I don't want to have my brain hurt. Now, how do you go about spotting these when you're doing reading in journal articles or other kinds of things? Now, in the journal articles, this shorthand of 2 by 2 or 3 by 4 or whatever it is very commonly used. This is the case of what you're learning in your textbook exactly shows up in journal articles with small variations, but you'll be able to pick them out without any difficulty. Journal articles that have factorial designs almost always use this kind of terminology because it is so clarifying for the reader as to what's going on. In popular press articles, though, they're not going to use that kind of phrasing. What they're going to tend to say is that one variable depends upon another variable. This is going to be the case when an interaction has been found to be supported in the in the study, that the action of, say, alcohol on drowsiness depends upon whether or not the person had taken a sleeping pill. You could also see it written up in popular press articles as saying that the effect is seen for one kind of participant but not for another kind of participant. And by the way, this is an important point for me to make here, is that whenever there's an interaction in a study, found in a study, you must interpret the interaction first. That main effects, while they're simpler to try to interpret, cannot be interpreted if you have a statistically significant interaction. That is, what we're trying to say with that is if we have what we were seeing earlier is an interaction between the alcohol use and the taking of the sleeping pill on drowsiness. What we would want to say is that even though there is an increase in drowsiness for taking the pill and an increase in drowsiness for taking the alcohol, that it's a greater degree of increase, and a lot of the apparent increase in drowsiness for taking the pill in our study seems to be due to the fact that the pill and alcohol are interacting with each other. So you have to take that into account. And in fact, it represents one of the things you lose a little bit in a factorial design, because if you have an interaction, it undercuts your ability to talk about at least talked in simple terms about the main effects. There is a further analysis that is allowed to be done called simple main effects analysis, where you examine what's going on at one level of an independent variable, then another and another. It gets kind of beyond where we're at in this course. It does allow you to break things down a little bit, but fundamentally, if there's an interaction, you cannot talk about the main effects without taking into account the interaction in your discussion of the main effects. So, to close what we've got going here, factorial designs are an efficient way to examine the effects of multiple variables on a dependent variable. The key is that 3 simultaneous research questions can be asked in each two-way factorial design. If we have more than 2 variables, if we have 3 or more variables, we would refer to that as a 3-way design or a 4-way design. And it also can get very complex, so caution is needed in design. It's easy to get a little bit out of control, get things too far flung, and have problems occur in your ability to interpret down the road. Keep it simple. It will almost always pay off with something that you can actually describe to another person, and that's key. Thank you for your attention. I hope you found this useful.